So, very good morning. I have been discussing about the embedded system, and I have been talking to you at length about the characteristics and its design aspects to some extent, and it has been how it has been useful in the modern day world using the embedded controllers in most of the gadgets or the household appliances. And as per this, if you see, the further and further, very important aspect of these controllers are going to be a microprocessor, which has been a silicon chip and which has been referred as central processing unit, where it could be associated with a certain software with calculation of the arithmetics as well as logical operations, and there's been used as instructions, and these instructions have been given to the processor so that it can able to execute the instructions properly, and whatever user wishes to have a result from that can be obtained and passed on to the external systems. So like that, the CPU has been a very powerful tool where it has been using certain registers also to store intermediate informations. So if you look at the block diagram of 8086 processor, where we could have a general purpose registers as ES, AH, AL, BH, BL, CH, CL, DH, DL, like that. And we also have segment registers where the extra segment, core segment, stack segment, data segment, in instruction pointers, etc., which has been of 16-bit length, where the core segment will associate with only the code information of the particular program. Similarly, further and further, if you want to go for a data segment, where I can able to obtain data relevant to the data has been stored into data segment. Instruction point to the current instruction to be executed, like that. There's a pipeline processing has been coming here because it gives a lot of a speed of operation. It fetches from a queue instruction stream which we have been made as a instruction queue. So this instruction queue has been used here, and it does a task of doing instruction passed on to the CPU from the control systems. So there's one arithmetic logic unit which does the operation of the arithmetics, and where you can have, once the arithmetic operation has been performed, it can have a overflow or underflow, or it can get a sign and all operations. Therefore, it can be referred as a flags. Flags have been associated with this. So by seeing the flags, I can understand that the arithmetic operation has been going on, how it has been perfectly matched on to, so that I can able to compute and remodify my data so it can be occurred within the range of operation. So like that, I could able to see that the very first of its kind, what I could see is a 86 processor, and also there is one next processor came into 186, which also been acting as a controller. People may not knowing that it's also acting as a controller. Later could find out that once they go for the higher and higher set of instructions and the technology advancements, they can have 286, 386, 486, and Pentium chips are coming to market, and which does the task of almost like a powerful mathematical tool for us to perform the operations. So therefore, further they could see that the energy, the memory management has to be accommodated. They can want for a memory segmentation, and also to connect to the external world with like a keyboard or a display or a printer, whatever you call it. And they have interfaces here, which does the task of transmitting the data to the outside world. So this is the brief introduction about the 86 processor. And similarly, I could see that the microcontrollers, which talk about now, will also have a CPU, a central processing unit, a random access memory, RAM, read-only memory, ROM, and also I/O ports where I can attach the external peripherals, and the timers like a standard computer. Timers have been provided here to note the eventualities and have a concurrency of the timing. So therefore, these timers have been having its own counters where I can load a count depending on the delay required, so that the timer can execute the delays also properly. So like that, I can have a microcontroller on chip where you can have certain built-in memory, so that it has been very, very powerful tool for us, where I can store intermediate information instead of going to the main memory, which is external to the system. So like that, we can also have, I said that there is a necessity for you to go for a signal processing chip, which has been here, TMCs have been given here, TMXE320, DSP processor has been extensively used in such type of applications. So therefore, if we talk about the memory in particular, the ROM, RAM, though we have the memories like this, read-only memory or random access memory or external device have been connected to this point, the mapping has been very important, because there are two types of mapping. One is I/O mapping, other is a memory mapping. So therefore, depending on the type of mapping, also one could able to see the accommodate more number of the locations for the I/O devices. Similarly, I said the interface has been very important. It is bridging the gap between the external world to the processor. So therefore, interface has to be properly matched. What matching means, it is mean a speed compatibility has to be achieved in this point. Memory shadowing, where I said memory shadowing is been replacing the ROM by a high-speed RAM, is called as the memory shadowing. That's what I could see, that which leads to a memory selection for embedded system. So therefore, this called as memory shadowing is also possible, so that as you know that ROM is read-only memory, RAM can be read and write memory. So therefore, the people prefer to have instead of a ROM, a RAM, and also there is a EEPROMs come into market. Bit eligible prompts is also, electrical eligible prompts is also available, which leads to a memory selection for every system. Next, we have a keyboard. The codes will be executed in a special ROM chip, which is called a BIOS. So it is the different locations have been allocated by the Intel manufacturers for each I/O operations in the ROM locations. So once you come back to sensors and actuators, and I have narrated here different types of sensors which have been used here, and it has been just narrated. You just go through. Once first pressure sensor, which has been used here, with I have given specifications here. You know the pressure sensor has been used here, and with a size, resistance range, and then a force range and power supply. Why you should know this is that pressure sensors have been selected for pressure applications, where I can able to measure the pressure using the force in terms of forces applied. So therefore, once you know specifications, I can able to see that this particular sensor has been suitable to be adapted for this embedded system or not. So therefore, if you see the power rating, it uses less than 1 milliamperes of current. Similarly, a temperature sensor. Temperature sensors are so many types of sensors are there, like thermostats, thermocouples, RTDs. Okay, so all these things have been used here, but depends upon the range of the operation. One has to select it. Here I have shown one temperature sensor which they've been calibrated and which has been on a linear scale of plus 10 millivolts per second degree centigrade. So the rated of full range, if you see, minus 58 degrees to 150 degrees centigrade, because the temperature sensor have been extremely used in the furnaces where the high temperatures has been going to be recorded. And then here I have given only a minus 55 degrees to 150 degrees range of sensors have been shown here, suitable for a remote application, and it has been a low cost dew wafer level trimming has been adopted here in this. So it has been referred, a commercial name is LM35 with pin number 1, 2, 3. Pin number 1 is 4 to 20 volts it takes, and then 2 is output, 3 is a ground. So all these sensors, when you do look at it, it is been converting from one form to other form of energy. So therefore, we give some inputs and we get an output. Okay. So temperature has been given as input, then it has been converted into output voltage. So therefore, like that, we could be able to see the temperature sensors has been used here, which is also a transducer. The difference between a sensor and a transducer is that the sensor will only senses the particular parameter or the variable, whereas the transducer can have both a sensing element as well as amplification, so that the sensor output may be very, very small, which cannot drive the loads. Therefore, we need to have an amplify this particular voltage or current. Therefore, we need to have an amplifier. So these amplifiers will also built into this point, which is being called as a transducer. So I can say, yes, sensor cannot used as it is. Therefore, I can have to have an transducer which does the task of driving force for other connected networks. Similarly, I have a gas sensor. Is a device which detects the presence or concentration of gases in the atmosphere. Based on the concentration of the gas, the sponsor sensor produces a corresponding potential difference on the resistance of the material inside the sensor, which can be measured as an output voltage. Based on this voltage value, the concentration of the gas can be estimated. So this has been very important because the gas, what type of gas has been used here? It is inflammable. Suppose I have a HB gas, or I have toxic gases and all coming out. So I have to sense its intensity so that how far it can affect my atmosphere. So therefore, one has to have a sensor conductivity should be known, which has been is higher along with gas concentration rising. So therefore, it also gives rise to a concentration of the gas can be measured so that I can able to find out its intensity and its impact on the other environments. So therefore, it should be a good sensitivity to combustible gas in wide range, high sensitivity to LPG, propane and hydrogen, long life and low cost has been very important. Simple drive circuit has been employed for these gas sensors. So like that, the gas sensors have been used so that the intensity of combustible gas can be found out and its conductivity so that we can able to estimate what will happen to make the environment safer and safer, not to have any sort of unpleasant situations. I have shown here the humidity sensor working. The moisture sensors has been taken here with a to D converter. You know that the moisture sensor gives analog output. That analog output has to be converted to digital form. Therefore, we need to have an analog digital converter. Then it is given to a processor unit. Then it has to operate to Internet of Things. Whatever you want, any device can be connected, driven, or do whatever you want to do. So therefore, Internet can be connected to this point so that we can able to regularly monitor. I have shown here the 3-lead moisture sensors where the orange is input where analog will be given. Green is ground. Red is output will comes to 5 volts depends upon the calibration of the output. So I also given here the ranges here for the humidity sensor voltages with a minimum of 3.3 volts, maximum of 5 volts. Current is 35 milliamperes and output value dry soil will have 300. Sensor in humidity soil is 700. Sensor in water is 950. Like that, I can able to get the output value depends upon the dry soil or humid soil or a water presence of moistures. What I could say, water means the moisture content into the point. Okay, so therefore the humidity has been found out. As you know, the weather forecast has been giving like that. They use these sensors and find out what should be humidity in the air or moisture content in the air. So like that, they have been giving a report so that I could be able to say whether I can have a chillness today or not having chillness, and depends upon the humidity point of view. So LDR has been here used here, and so it is a photoresistors has been high resistance semiconductor, a photoresistor or less light sensitive device than a phototransmitter. I have been given here a light intensity versus a resistance. So as the intensity is going on increasing, the resistance has been decreasing with a light intensity. So this has been a curve which has been shown here. Therefore, I have to say that how LDR can be used, light range for devices. So here I have given here, suppose moonless is there, illuminancy will be 0.02 lux, and where you have full moon will have 0.27 to 1 lux, okay, in the clear night. So dark when it comes to 3.4 lux, like that. So family living room should have 50 lux. Hallway toilet should have 80 lux. Very dark overcast day is 100 lux. Therefore, these sensors controls the intensity of light within the room or wherever you call target. So therefore, I could give ranges here. Full moon will have maximum 1 lux, and moonless clear sky will have 0.022. So depending upon that, I can able to say how much luminosity is needed for any of the room, drawing room or bedroom or a bathroom, etc. So like that, we can able to make use of the LDR sensors as a tool in all the embedded system where the intensity of light can be controlled within the rooms. So this has been very, very important is that A to D converter. The people may think simply that A to D converter is very, very simple topic. But if you see, you look at it, the conversion process, because I have been giving analog input, I have been expecting a digital output. Between this, it is a conversion process. This processing time should be minimal so that I could able to get digital output earlier. Because if the processing time is lengthier, what will happen is the analog signal changes within the time of delta. So therefore, whatever digital output coming over there, it may not be matched with the input point. So therefore, it is such a critical analysis has to be made that how much signal has to be given and processing time so that the signal will not be lost during the conversion time. Therefore, it is so specific that the A to D converter time has been very, very important so that the things will not be perfect. So therefore, the A to D converter should have its own clock of conversion because it has been almost different from the system clock. System will have its own CPU clock, but it's not the same with respect to ADC clock. It is much reduced by more than 10 times of ADC clock. So which has been used here to sample the signal, analog signal, and given to the A to D converter, which does the translation or conversion of the signals. These two stages allow a speech waveform to be represented by a sequence of values with each of the values. So therefore, if you don't want to see that input should not change during the conversion time, one has to use a sample hold circuit. Okay, I have been showing here the microchip technology which has been used, successive approximation. And there are so many things have been there in the technology to convert A to D converters. One is a successive approximation, other is a ramp technique, other is a the integration type, dual integration type, like that. But among all these things, what I could see is that the successive approximation of 12-bit analog is being extensively used in most of the applications because it takes less number of time for iterations of conversion. So therefore, the people prefer to go for this sort of a microchip technology based AD converter, which is being referred as MCP 3204/3208 devices or approximation type. So it also provides pseudo differential input pairs, and where the first stage, if you see, there should be a differential inputs have been applied to the A to D converter. Okay, as like that, I could see that the broad voltage range is going to be 2.7 volts to 5.5 volts. So this I again here a pin diagram where it's been a VDD has been a supply. V reference is almost generally a 0. Then there is a ground point. There is a clock to be given for A to D converter, and D out is a digital output, and then D in, data in, and then CS bar chip select, because there are so many chips available here. Which chips has selected will be indicated by this pin number 10. Then I have a data ground. Then I have a channel 0 to 7 channels. I can able to give 8 parameters here to convert it. Therefore, the variable 1, variable 2, variable 3, variable 4, variable 5, variable 6, variable 7. Like that, 8 variables can be applied simultaneously to this particular microprocessor so that every analog input can be converted into a digital form. Comes back here once again another sensor which has been referred here as accelerometer. In most of the automotive mobiles we could see, these cars and all, where I have accelerators which has been controlled with an embedded system. So therefore, this sort of accelerometers have been employed here. The range has been given here, how it has been used, and XY axis is a tilt and Z axis is a gravity. So like that, how the accelerometer works is that it calculates and computes the angular velocity and then finds out the accelerations so that how much has to be applied, and there's automatic gear system available now which can be used, these accelerometers, where the cars can be driven with a automatic range of controls with accelerators. Now coming back to angular velocity sensors, which has been called as the gyrometers. Gyrometers has been used here. It finds out the angular movements, angular variations of the particular point, and the tri-axis angular rate sensors with the sensitivity up to 131 LSB, and full range is going to be here, and then communication protocol has been employed here. Chip built-in 16-bit ADC, 16-bit data output. Okay, so therefore the gyrometers have been actually used just to compute the angular rate sensors. So angular positions have been controlled with different angles so that I can be able to get the velocity from that. They can compute the velocity. So again, we have been using here a 16-bit ADC, the 16-bit data output. So the protocol, communication protocol, as you know that so many protocols are available here, and among which the I2C has been selected here as a protocol. So this next we'll just think of, once we have seen the sensors, we'll just think of what is actuators. Okay, we'll just see in the next class what should be our accelerators. Okay.